Okay, to continue what I was saying, an arrow gives the direction and the length gives the magnitude or the strength of the vector. If they wish to talk about the magnitude or the length only, they call that the absolute value of a vector. It's kind of like what's its distance from zero, what's the absolute length of it. Doesn't matter what direction you're headed. So absolute value of u equals the absolute value of v means that their magnitudes are equal, but not necessarily their direction. For vectors, the vectors above, u equals v, but u does not equal w. However, u does, the absolute value of u, or the length of u, does equal the length of v, which does equal the length of w. So that is true that their magnitudes are the same. They're just not going in the same direction, so their actual vectors are not the same. Okay, if we continue on over here to the next page, okay, we're going to do a little bit of some vector addition here in section 1. They're going to ask you tonight to draw the addition of some vectors. And tonight, you can see when they say you're going to be drawing vector AB, that means you're going to be going from point A to point B. When it goes like this, that means you start at A, you're going to end at B. All right? And plus vector BC, you're going to start at B now and end at C. And they're going to say that that equals starting at A and ending at C. It's called the resultant, and it's vector AC. So for example over here, if you start at vector A and you go straight down 15, you've gone from point A to point B, this is vector AB, and then you're going to add to that vector BC, so you're going to start at B and move to C. Again, notice that they have length and they have direction shown by the arrows. One's 15, one's got a magnitude or a strength of 10. The resulting vector will be AC, starting at the same spot, ending at the same spot as AB plus BC. So they don't look like you're not adding like 15 plus 10. The resultant is if you were driving a ship this way and the wind was blowing you this way, this would be the resulting path you would have to take. So this is called the resultant. AC is the vector sum of vector AB and BC. You must follow the path of the vectors. If you start at some point and you add vector A to vector B, from the start to the finish would be vector A plus B. So the dash section right here would be A plus B. It is the same thing as taking B and adding A to that. You can see if I turn around and add A going up this direction, this vector looks exactly the same direction and the same length as this vector. They are the same. But notice you still follow AB, or vector B plus vector A. If you drew them into a parallelogram, you can see A plus B is vector AB, which is the same as B plus A would be the vector AB. It is not the same as starting at one point and going A and B. You have to connect the vectors together from start to finish. You have to now connect the vector B here and draw it this direction if you're going to add the vectors together. You can't say this plus this equals the vector going this direction. It's not the true case. These two, this resultant is not the resultant of adding these two together. They must follow a path of the arrows. All right, so it's going to ask you tonight to make the scale drawing or show a force of 20 newtons pulling an object east. Okay, so they just want you to draw that. I don't care where you start on your paper. Just make sure you're drawing a vector that's going due east, so it must have the arrows pointing east, and then label it 20 newtons. Because the next thing they're going to ask you to do is draw a force of 10 newtons. Well, your 10 newtons should be half that length or half that strength, pulling an object in the compass direction of 150 degrees. Compass direction is important. You need to know that compass direction is measured from the north this time, clockwise. Whenever you talk about vectors, they always say you're going in a compass direction. It's also called a bearing, a course, or a heading angle. all of those are measured from the north clockwise. So if you're going to be going on a compass direction of 150 degrees, 150 degrees means this is the direction that the ship is going, or that the object is being pulled. At 10 newtons, it should be half this strength, so it should be about half that length at a compass direction of 150 degrees. Okay, so if these two forces were to work together, draw and estimate the resulting magnitude and direction. Okay, so if you start off and you have a force of 20 newtons pulling an object east, and then working on that object is another, perhaps a wind blowing or whatnot, blowing at 150 degrees at 10 newtons. Okay, so you've got the 20 pulling it east, the wind blowing it at 150 degrees. The resultant would be going from the start to the finish following the path of the arrows. This would be considered the resultant. So if you were going to draw that just as what we were talking about, you would have, you could do the, down here I'm showing that you could go 10 first if you want, then the 20. This resultant is the same as this resultant. For some reason students like to do this, but you cannot start and go 20 and go 10 from the same point. Where's the resultant? This is not the resultant. The resultant is going in this direction with this magnitude. It must follow the path of the arrows. Okay, the last thing I would like to talk about will be vector subtraction. We talked about vector addition. If you want to take vector v and you're going to negate vector v, it simply means you're going to move in the opposite direction. So instead of going northeast, you're going to be going southwest. Okay, the opposite direction but the same magnitude. If they ask you to draw and tell you that this is W and ask you to draw V minus W, you would draw V, which is going in this direction, which is fairly northeast. And then you're, instead of going due east with W, you're going to go in the opposite direction of W. So this would be negative W now. So V minus W would be the resultant from start to finish of V minus W. This would be the resultant, or V minus W. 2W means you're going to go in the same direction, but you're going to have twice the magnitude or twice the length. So if this was W, 1W plus 1W, this whole vector would be 2W. Negate or minus 1/2 V would mean you're going to go in the opposite direction of V, so this direction, half the magnitude. So you can see half the magnitude in the opposite or negative direction. Okay, so tonight they're going to ask you on some graph paper, they're going to give you vector U and vector V, and they're going to ask you to draw U plus V, 2U plus V, and U minus 3V. I want these done on graph paper. So start at any point you want. I don't care where you start, but draw U, and that means I'm going to be moving over 2 and up 4, it looks like. So over 3 and up 4. So I'm going to start at this point. I'm going to move over 3 and up 4. That dashed spot right there would be the U. And I'm going to add to that V, which is over 1, 2, 3, 4, 5, and down 1. So to this end, I'm going to add over 1, 2, 3, 4, 5, and down 1. So U plus V will be this resultant right here, which will be the U plus V. 2U plus V means I'm going to need to move over 3 and up 4 and over 3 and up 4 twice. This is 2U, and to that I'm going to add on V, which is over 5 and down 1. There's V. So this resultant right here is the 2U plus V. Okay, last of all, if I want to do U minus V, again, find a point. I'll start right here. I'm going to draw U over 3 and up 4. There's U. And now I'm going to add negative 3V. So instead of going over 5 and down 1, from this point, I'm going to go back 5 and up 1. There's negative 1v. Back 5 and up 1 is negative 2v. Back 5 and up 1 is negative 3v. So u minus 3v will have the resultant right here of u minus 3v. Okay, now you guys have got enough to start your homework tonight.